Okay, so let's try this with a 3 by 3 matrix. So we have A, which is going to equal 1, 1, 0, 1, 0, 1, 0, 1, 1. And we're going to try to find the inverse matrix that is going to be associated with this matrix. And if you watch the video on the chicken problem, um, this is where that actually comes from. So what are we going to do? We're going to augment this with the identity matrix and try to move the identity matrix over to the other side. Okay? So let's say, all right, we'll start with this one on this side. 1, 1, 0, 1, 0, 1, 0, 1, 1. Okay? Now augmented with 1, 0, 0, 0, 1, 0, 0, 0, and 1. Okay, so the first thing that I want to do is all right, so I'm trying to get the identity matrix onto this side of the problem. So the first thing I want to do is I want to eliminate that one right there. Okay? So I'm going to take the top row, the entire top row, and I'm going to multiply by -1, and I am going to add downwards. Okay. 1, 1, 0, 1, 0, and 0. So the top row is not affected. 0, 1, 1, 0, 0, and 1. And so the bottom row is also not affected. The only thing that's going to be affected by this operation is going to be the middle row. Okay? So if I take this row, I multiply by -1 and I add it downwards, so -1 times 1 was -1 and added to 1, that gives me a 0 right there. So that's what I was looking for. Okay. Now taking this component right here, say multiplying by -1 and adding downwards, that's -1. This one's not going to be influenced because multiplying 0 by -1 doesn't do anything. And so this would be a -1, a 1, and a 0. Okay. Now the next thing that I want to eliminate, you want to eliminate the lower triangular portion first. So I need to get rid of that guy right there. So I'm just going to take this row and add downwards because that -1 and the +1 will cancel each other out. Okay. So I'm going to take this row and just add it to the bottom row. Middle row added to the bottom row. So that would become 1, 1, 0, 0, -1, 1, okay. And then 1, 0, 0, -1, 1, 0, and 0, 0, and then 1 plus 1 would be 2. Right? Now adding downwards, this would be -1, 1, and 1. Okay, I'm going to run out of room on this page. All right, so remember, we want to get the identity matrix onto this side of the problem. So now we're at this point right here. Let's take this entire row, this bottom row, and let's divide by 2. Okay, because we want a 1 right there. Okay, so if I take that row and I divide by 2, what am I going to end up with? This is 1, this is 1, this is 0, this is 0, this is -1, 1, 0, 0, and 1, okay? And then 1, 0, 0, -1, 1, 0. And this would become -1 divided by 2, 1 divided by 2, and 1 divided by 2. So now that you have zeros in this lower triangular region right here, what we want to do is we want to get zeros here, here, and here, and make sure that that turns into a positive one. So what we're going to do now is we're going to use this element right here, this entire row, and I'm going to use that one right there to eliminate the one that's above it. So whenever you do this, you want to do this in a counterclockwise form, where you use the first row to go down and knock off these elements, then use the middle row to attack that guy, and now I'm going to use this guy, and if there was a number right there, I'd use that to attack that one, but we're going to take this one, we're going to use that to turn that into a 0. So, take the bottom row, and we're going to multiply by -1, and we're going to add upwards. Okay. 1, 1, 0, 0, -1, 0, 0, 0, and 1. Now augment with 1, 0, 0, -1 divided by 2, 1 divided by 2, and 1 divided by 2. Okay. Now we have to consider what's going to happen to that middle row. Put that out of the way. Okay. Now, if I'm taking my bottom row and multiplying by -1 and adding upwards. So, -1 divided by 2 being multiplied by -1, so that would turn this guy into a positive 1/2. A positive 1/2 and a -1 would become -1/2. Okay. Now, -1/2 and a positive 1 would become a positive 1/2. And then -1/2 plus 0, that's just -1. Okay. Now, at this step of the problem, you could say, well, why don't I go ahead and multiply this entire middle row by -1, and so that I'd have a 1 right there. Yeah, you can do that. But the other, what we want to eliminate from this is going to be this positive 1 right here. And now if I just take this row and I add it to that one, well, it'll cancel it out. And then we can multiply by -1 afterwards. So let's just do that. Let's take this row and add it to the row above it. And so that's going to become 1, 0, well, 0, 0, -1, 0, 0, 0, 1. Let's augment this. And so the bottom is not going to change. The middle's not going to change. But this is. And so -1/2 plus 1, that's a positive 1/2. It's a positive 1/2. And that's a -1/2. Okay. Now you can think of this as multiplication or division. Let's say, for consistency, let's say we divide it by -1. One, 0, 0, 0, 1, 0, 0, 0, and 1. Okay. So that is my inverse matrix of the original matrix that I was dealing with. Why don't we check our answer to see if this really actually makes sense? So, let's take our matrix, the inverse matrix, 1/2, 1/2, negative 1 half, 1 half, negative 1 half, 1 half, negative 1 half, 1 half, 1 half. And let's have it act upon 1, 1, 0, 1, 0, 1, 0, 0. I mean 0. That's a 1. 1. Okay. Now remember, this is row acting upon column. So 1 half, 1 half, negative 1 half acting upon this one, that becomes 1 half plus 1 half. So that's 1. Okay. Now this row acting upon the second column, what would you get? We would get a 1 half and then we'd pick up a negative 1 half. So 1 half and negative 1 half would cancel each other out, and so that would be a 0. Okay. Now when we have this row act upon the last column, okay, so this guy's going to turn into a 0, and what are we left with? We're left with 1 half and negative 1 half. Well, 1 half and negative 1 half cancel each other out, so that turns into a 0. All right. Now 1 half, negative 1 half, this row acting upon this column right here, well, that guy's going to go to 0, and we're left with 1 half and negative 1 half, so they're going to cancel each other out. Okay. Now, if I take this row and act upon this column, what's it going to pick up? It's going to pick up, this negative 1 half is going to disappear because that's going to be multiplied by 0. And so we're going to pick up a 1 half and a 1 half being multiplied by the 1s. So that's going to turn into a 1. Okay. And now 1 half, negative 1 half, 1 half, this row acting upon the third column. Well, this guy is going to go towards 0, and we end up with negative 1 half and 1 half, which cancel each other out. So that's going to turn into a 0. Okay. And so now we're taking the bottom row and acting upon the columns. So we have this negative 1 half, 1 half, 1 half acting upon that column right there. Okay. And so now what's going to happen is that guy's going to go to 0. We will end up with negative 1 half and 1 half, which will cancel each other out. So that would become a 0. All right. Now negative 1 half, 1 half acting upon this row, acting upon this column, this term will go away because that's going to be multiplied by 0. And then we have negative 1 half and 1 half, which cancel each other out. And so that becomes a 0 right there. Right? And now when we have this row act upon the third column, well, what's going to happen is negative 1 half is going to be multiplied by 0, so it's going to disappear. Okay? And then we end up with 1 half and 1 half being multiplied by the 1s, and so 1 half plus 1 half is 1. And so we get a 1 right there. And so we get a big check mark. Yes, we found the inverse matrix for that problem. Okay?